Today we're going to continue with our BizTalk to Azure Migration series. And what we're going to talk about is implementing the publish and subscribe pattern on Azure. So if you recall, back in BizTalk days, everything needed to come in through a receive side. So a receive location, receive port, everything had to come in like that. Everything went into the message box, which is just a database. And then from there, either for orchestrations or for send ports, you had filter expressions that would then route that message to go out. Now that made you implement the publish and subscribe pattern, whether you wanted to or not. Even if you wanted to go from A to B, you had to put publish and subscribe in the middle. Now with Azure, you don't have to do that. If you want to do A to B, you can do that by just creating a logic app or something like that, just as A to B. However, there are times when you really want to do a publish and subscribe pattern. Sometimes that might be because one message comes in and you want it to go to multiple different systems downstream. It may be that some of those systems downstream are not always available, and so you want to make use of some queuing capability. It may be that some of those systems are only interested in some of the messages and not all of them. So these scenarios lend themselves to the publish and subscribe pattern. It's one of the most important integration patterns you can learn. Now in Azure, we have a wealth of ways in which we can do this. But the go-to one really is Service Bus. Azure Service Bus. It's the oldest kind of messaging platform in Azure, and it's really the Swiss Army knife of messaging. It does all these things. Maybe it doesn't have the highest performance, the highest throughput. We'll get onto that. But it's definitely got the richest functionality. So if you want to send a message onto your service bus, you create a topic. Different systems can write to that topic, and then different systems can have a subscription and take messages off that topic. So creating subscriptions is a key part, but that implements your publish and subscribe. Whether you want to pull those messages off with a logic app, whether you want to pull them off with an Azure function or some other code that you've written, it's all there. So Service Bus, very flexible. It allows you to do other things, not just publish and subscribe. Very good at high integrity persistent messages. So if you want to do peak lock patterns, so I'm going to process this message, but I'm only going to mark it as being consumed once I've finished working on it. Really good for the very high integrity, must not lose this message scenarios. So Event Grid comes from a very, very different background. Event Grid is much more lightweight, very flexible, very scalable type of messaging platform. Originally, it wasn't really there for high integrity. It was like events in a programming language. Something raises an event, and that event is only processed if there are listeners to it. That's how Event Grid started off. So you could raise an event to Event Grid. If nothing else was listening, that event disappeared. Since then, it's become persistent. So there are persistent options for Event Grid. So it's much more usable for scenarios where the downstream system might not be available, and that kind of thing. But one of the things that you're really good at with Event Grid is high volume. So small messages, high volume. Service Bus can handle quite big messages. Event Grid, if you've got high volume, small messages, IoT is a key scenario here. This is the core foundational technology that sits behind IoT. So high volume, lightweight, and you still can persist them, but often you just want to process them very quickly. If you're getting telemetry data, do you need every single item of that telemetry data? If you lose a couple, is it the end of the world? Event Grid is good for that. Tons of data. So that is very, very, very flexible. Really want to look at that as something particularly for those high volume applications. And then finally, we've got event hubs. Now, event hubs are a different thing again, and they are more like Apache Kafka. So they're for streaming data. So you can stream data onto an event hub, and then you write consumers to read that data, and you can have multiple consumers. So again, it's less event-based and more stream-based, But if you have got lots of data coming in and you want multiple different downstream systems to be reading copies of that, then this is another technology you can look at. So what's good about Event Hubs? Well, first of all, streaming data is really high volume. It can handle tons and tons of data coming in very fast. So if you've got bursty workloads or something like that, really good for that high volume. As I say, it's streaming, so it's that continuous flow. You've also got interesting ways of recovering, because what you do with an event stream like this is you're writing effectively a sequence of, it's like writing a sequence of entries in a table, each of which has got a number. And then your consumer just reads down, yeah, I'm going to go to number 1 first, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you get a problem, what you can do is you can reset the pointer and you can read that stream again. So you've actually got different ways of recovering from that. So Event Hubs are probably the biggest change in mindset, because it doesn't really, BizTalk workloads don't really work like that. They're much more going to fit into the service bus or the event type of pattern. But in terms of if you need to have a way on Azure to write data into one place and multiple different systems subscribe to that, those are your options. So if you want to find out the one that's the best for you, talk to me. We can find the best answer.